7C, applications in 2 dimensions. We want to look at some questions today that are word questions a lot of the time. We're going to be using angles of elevation and depression and compass bearings to help us to find things in triangles. So it's still be using SOHCAHTOA, still finding sides and angles using SOHCAHTOA. Okay, so let's go through the theory part. First of all, angles of elevation. When you're doing angles of elevation and depression, it always starts from a horizontal line. You've got to think, here's my horizontal line, and elevation goes up from the horizontal, and an angle of depression goes down from the horizontal. That's it. That's all there is to it. So here's my angle of elevation going up. And here's my angle of elevation, my angle of depression going down, all from the horizontal line. Now, when we're talking about a person on a building, it's often the question that you get. So here is a person standing on the building, and there is an angle of depression, which has to be from the horizontal line, and it needs to be the angle going down. The problem is, that is not one of the angles in the triangle. So this is just a little reminder that we can use a little bit of geometry in here. An angle of depression, you often just use alternate angles to move whatever this angle is straight down into there. Okay? All right, here is the example. Number 1. From a cliff 80 meters high, the angle of depression of a boat at sea is 15 degrees. So you need to be able to draw accurate diagrams. Sometimes that is the hardest part, getting started, getting the diagram right. So this one, we have a cliff. It doesn't have to be a piece of art that we're drawing here. Here is my cliff. It's a line. Okay? The cliff is 80 meters high. The angle of depression, which means if I'm imagining that person standing on top of the cliff, the angle of depression, there's my horizontal line. This is not to scale. My angle of depression would be that angle in there, 15 degrees. How far is the boat? So there is a little boat out here on the water. There you go. That's about the extent of my artwork, people. How far is that boat from the edge of the cliff? So as I said before, if I have that angle of depression, the first thing I should do is use alternate angles to move that 15 degrees into the bottom of my triangle. Then I'm trying to find this distance, the one between the boat and the cliff. So I need to label that side. I've called it X. So I've got an angle. The side straight across, the 80 degrees is going to be the opposite, and the X is the adjacent. So using SOHCAHTOA, which trig function am I going to use? Tan. Excellent. So I write down tan theta equals opposite over adjacent. Subbing in, tan, my angle is 15, equals opposite is 80 and adjacent is X. If X is on the bottom, that means that it's going to switch places with the tan 15. So X equals 80 over tan 15. And then you just need to type that into your calculator. Keep an eye on your question to see if it tells you where to round it, because often it will. This one doesn't. So I just went to 2 decimal places and I got 298.56 meters to 2dp. Okay, everyone okay with that question? Yeah. Good. Question 2. 2 buildings are 30 meters apart. We do have most of the diagram here for us. So we've got our 2 buildings, and you can see there's the 30 meters apart. And a rope is run between them as shown in the diagram. So the rope is the sloping one between the tops of the 2 buildings. The buildings are 43 meters high and 11 meters high. So that's not on the diagram. You better add that. The 43 would have to be the higher building, and that makes the 11 meters the smaller building. Find the angle of elevation from the top of the smaller building to the top of the taller building. So that's the theta in there I'm trying to find. So it would have to be a right angle triangle in here, even though it hasn't stated that. To find another side in that triangle, I need to do 43, take away the 11. Okay, if I do 43 is this whole big height, if I subtract off the 11, then I know that this little side in here would be 32 meters. Does that make sense? Okay, so now I have two sides in my triangle and I'm trying to find the angle. Which sides do I have? Opposite and adjacent. So it's tan again. Tan formula. Tan theta equals opposite over adjacent. This time I'm trying to find the theta. So it will be an inverse, yes. The opposite is 32. The adjacent is 30. So to get that theta, anytime you're finding an angle, you're typing it in inverse tan into your calculator. It does say in the question, looking back here, to the nearest minute. So type that in your calculator. If you type it in, shift tan or inverse tan of 32 over 30, press equals. Then you need to press your bubble button to make it turn it into degrees and minutes. What do you get? 46.51, good. We actually end there. I thought we'd get to go on to the bearings part today, but that's actually the next exercise. We're just sticking with elevation depression today. Easy peasy. All right, 7C.
Do you have any spare books?